So just looking at the question which I've designed for this portfolio, it is kind of a two-part question. So on the first page, students go through the principles of constructing the octahedral geodesic dome. So as you can see in the top corner, we have construct a square of 25 meters squared, showing all key principles. You may scale the dimension to fit the page. So obviously, students are going to be dimensioning the square down. Moving on, we have divide the given line into equal segments. Project point B1 from plan to the edge view to find points B2 and 3 on the dome. Follow the same procedure as A1 and explain the rationale. So as you can see, I have shown a partly completed octahedral dome. So students have been shown how to find points A1, A3 and A2, and they are given points B1, B2 and B3 and asked to copy the same procedure. And then lastly, we have students bisect the given line and show all the principles behind the procedure. So these are just the four kind of key principles which are centered around constructing the geodesic dome. So moving on to the second part, a gardener wishes to build a self-supporting structural greenhouse in his garden. He has an area of 25 meters squared to work with. Construct the geodesic dome, a 3V octahedral, to form the greenhouse. So I chose this type of question to make students see the kind of real life aspect of a geodesic dome and where they would actually use it in their lives. So looking at the solution to the question, we have a square, just a simple square drawn, 5 meters by 5 meters gives 25 meters squared. We have the line divided into equal segments, so stepped off, your line stepped down and arc swung at equal line distances and projected back up to your original line. Then looking at the projecting the points, we can see the completed drawing down here. So lines are copied across from B2 and B3, similar to as they were done in A1 and A2. And then lastly, we have the bisecting line showing the key principles. So students can see that there's congruent triangles used when they're bisecting a line. So looking now at the gardener question, we can see the completed octahedral question. I chose to do octahedral because all lines lie on the ground in comparison to icosahedral, where there's points of the dome raised above the ground and only certain ones are actually touching the ground. So you can see all the key principles are shown down here. You have your lines are your line is divided into equal segments to find your three triangles down here. You have the bisection of the line to find the center point. You have the projecting your points across and the initial completing of the square for the start of the question.